8.2 today. This is area between curves. One thing I like about this section is that it, for the most part, it follows the, the structure of the section of the concepts is pretty intuitive. So let me set this up generally here. So we have the function y equals f of x. And suppose that we have below that the function y equals g of x. Okay, it doesn't matter what these functions do really. Okay, so we have g of x and f of x. So we go from, some point on the x-axis a to b. And again, on this interval, f of x is always above g of x, okay, on the interval analysis. If we want to find the area between these curves, what we're going to do is just integrate from a to b. And then if you were to think about this, remember, any integral is just an infinite Riemann sum. So if you were to think about this in terms of just the one representative rectangle here, what you would do to find this height of the rectangle is you would take whatever the function value is of f here, and take away whatever the function value is of g down here. And by doing that, that would take the whole thing, this entire gap, or that entire piece, and then it would subtract off the gap, right? So we can extrapolate that to the entire interval, so it would look like this. It would be the integral from a to b of f of x minus g of x, all with respect to x. Okay, and so that is the general setup. So if we do an example here, I don't know why my pen is going slower than what I'm moving it, but anyway, so if I give you this, f of x equals secant of x, and g of x equals sine of x, what you get when you graph these is you get something like this. Secant does one of these things, like that, so that's secant of x. And then sine starts at 0, 0, of course, and does something like this. And suppose that we want to look on the interval from 0 to pi over 4. So if we look on that interval, so that'd be from 0, and then pi over 4 is somewhere in here. So there's pi over 4. This is actually bad representation of sine. Sine is going to max out at pi over 2, not pi over 4, but kind of ignore that if you would. Then if we want to figure out what this area is, all we're going to do is take the integral from 0 to pi over 4, and we're going to take the top function, which is secant. We're going to subtract off the bottom function, and integrate all of that with respect to x. And what I end up with is, just putting this in our calculator, because I don't know that we know the antiderivative to secant. But anyway, what we end up with is 0.585, right? And that's it for that one. We'll do one more example. This is going to work for no matter what, whether it's all above the x-axis or not. And so let's look at an example here. So where we have that situation. So we'll take a look at f of x equals 2 minus x squared, and then we'll look at y equals negative x, and we'll find the area between them. And also in this situation, we won't need to stipulate the bounds. So sometimes this will happen. I'll show you a picture of the graph here. So this one has a, the first 2 minus x squared has a y-intercept of 2, and it comes around like this, and like this. All right, and then you have y equals x, something like this. And this is the area that we are looking for. Okay, and so this point down here and this point down here, you would have to find those intersections, and this one turns out to be at x equals -1. This point right here turns out to be at x equals 2. This point is actually 2, -2. And you can do that algebraically by setting these two things equal to each other. Obviously, using Desmos or graphing calculator makes finding the intersection pretty straightforward, but then all it is taking the top function minus the bottom function on the given interval. So we're going to integrate from -1 to 2 on 2 minus x squared. That's the first function, or top function, minus the bottom, which would be minus the negative x, so plus x, all with respect to x. All right? And you end up with, when you solve that, you get 4.5. And I think that's it. I've got a couple more examples here. I'm not sure that we really needed them. It is really just the same process. Sometimes you got to do a little work to find the intersection if it just gives you an area that's bounded to find those intersections. But otherwise, that's it for the first part of section 8.2, finding areas between curves.